The 33% agentic threshold. Autonomous agents now generate 33% of global internet traffic. This is no longer just bot scraping or search indexing. According to the March 2026 Human Security Benchmark, agentic traffic grew over 7,000% in the last year, with machines now transacting on checkout pages and managing authenticated sessions independently. Your current Wi-Fi 7 hardware is designed for human browsing patterns, not the relentless, high-concurrency demands of a dozen local agents. This shift is why Qualcomm is moving the neural processing unit from the phone into the router infrastructure with its new Dragonwing architecture. Prioritizing reliability over peak speed. The Wi-Fi 8 standard, or 802.11 billion, is currently in Draft 2.0. Unlike previous generations that chased meaningless peak throughput numbers, the 802.11 billion specification focuses on ultra-high reliability. The goal is a 25% reduction in 95th percentile latency. Think of it like moving from a faster car to a wider, more predictable highway. By prioritizing coordinated spatial reuse and multi-access point coordination, Wi-Fi 8 aims to eliminate the jitter that breaks real-time AI inference. It is an engineering pivot from raw bandwidth to wire-like stability. The NPU as Network Arbitrator. Qualcomm's Dragonwing N Pro A8 Elite includes a dedicated hexagon NPU for a feature they call predictive quality of experience. Instead of basic packet headers, the router uses local inference to classify traffic types in real time. It identifies whether a burst is a high-priority agentic request or background data syncing. By running these models locally, the router can adjust interference mitigation and beamforming parameters every few milliseconds. It is the equivalent of having a dedicated engineer managing your spectrum minute by minute, but with the power consumption of a standard networking chip. Why traditional QoS fails now? Standard quality of service handles traffic using static rules, which worked when human video streams were the primary load. But agentic traffic is uniquely volatile. An AI agent might visit 5,000 product pages in the time a human visits 5, creating massive, unpredictable microbursts that saturate router buffers. The Dragonwing architecture uses its NPU to predict these spikes before they happen, based on historical telemetry. A potential drawback is the local privacy cost, as the router must analyze traffic patterns deeply to be effective. This creates a friction point between network efficiency and user data anonymity. The part no one wants to say, the integration of neural processing units into the networking stack signals that we are moving toward an era where the network is an active participant, not just a passive pipe. By combining the predictive QoE from the NPU mechanics with the massive shift in agentic traffic volume, Qualcomm is essentially building a sensing fabric. This infrastructure will soon be used to offload compute-intense AI tasks directly to the access point. For builders and devs, this means local latency is no longer a fixed variable, but a dynamic one that can be optimized through hardware-level inference. The real indicator to watch is the IEEE AI Offload Study Group. Their first formal standard amendment is expected late in 2026, which will define how these routers officially begin serving as edge compute nodes for the agents they currently only transport. Subscribe for more.